Ready? We're going to pretend you're ready. All right. 1-4, angle measure. The concept of today is not new to you. You guys already know pretty much everything I'm going to tell you today. Maybe the math is a bit new, but like you guys already know what an angle is. Does that make sense? So we're going to talk about it with fancy terms, I suppose, but you kind of already know what I'm saying. So just look up here really quickly. What kind of angle is this one? Acute. Very good. What about this one? Obtuse. Right. You guys know what I'm talking about. Okay? So we're going to start with a ray. When you were little, what did they tell you to think of when you talked about a ray? The sun, right? The ray starts at the sun, goes forever in one direction. Same thing. So the way we have it, a part of a line that has exactly one endpoint, so the sun or whatever, and extends indefinitely in one direction. It's named by the endpoint with any other point on the ray. So for example, this one could be called ray PR, forever one direction, or PS, forever one direction. I have to start with P though, not an option. Do you guys get that? I cannot call this RS because that's not the endpoint. Is that okay? Okay. Opposite rays, obviously rays that go in opposite directions, right? So two collinear rays with a common endpoint. It looks like a line, which how many degrees are in a line? 180, right? So I have ray PR and ray PQ. Yours is right, mine is not. So PR and PQ. Even though PQ is going to the left, you don't write it that way. You still always start with your endpoint, and we always draw the arrow to the right to indicate it's an array, to indicate it's a ray, excuse me. We're not indicating which direction it's going. Does that make sense? So always write it going left to right with the arrow. Does that make sense? Okay. Don't write that. That's what I'm saying. Don't do that. Okay? Angle. It's formed by two non-collinear rays with a common endpoint. What do you call a common endpoint? If you look up here, two non-collinear rays with a common endpoint. What do I call this? Right here. What did you say? Vertex. Very good. Yep. That common endpoint is called a vertex. So probably put that in. Okay? It divides a plane into three regions: interior, exterior, and the angle itself. When you hear the word interior, what do you think? Inside. When you hear exterior, outside, and then on the angle would be on the angle, right? So here's how you can name an angle. We've been talking about how to name things so far. So with an angle, you can give it 3 points, but if you do that, the vertex has to be in the middle. Write that in. You can name it by 1 point, the vertex only, or a number, and I'll show you what that means in a moment. Okay, so for this angle here, where's my vertex, A, B, or C? B, right? So if I'm going to name it with the 3 points, I can call it angle ABC or angle CBA, either way. So let's add that in there. Okay, as long as B is in the middle, it's fine. Okay, I cannot call that angle ACB. That's not the same thing. Do you guys get what I'm saying? Okay, I could call it just angle B, the vertex. I could call it just angle 1. All of those are acceptable ways to refer to this angle. Is that okay? Okay. The sides of it are rays BA and BC. See how I start with the B? And then I go to a point on it, and the ray goes forever to the right every time. Okay? And then the vertex we already said was B, right? What would you call this part of it? Interior, exterior, or on is what I'm looking for. The interior, right? What about this? Exterior. What about point A? On. Is that okay? Okay. Down here, it's the same concept, but I cannot call this right here angle B. Why not? Because there's a bunch of them, right? So I have this angle here, I have this one here, and I have this one. All of those technically are angle B. Do you see what I'm saying? So here we have to be specific. Here we have to use the 3 letters. Up here I didn't have to because it was just the one angle, but down there there's 3 of them. Okay? So if I'm referring to this angle here, what's one option? ABC, what's another one? CBA. If I put a 1 there, you could still call it just angle 1. That's fine, but you cannot call it angle B. Okay? What about this angle here? CBD or DBC or angle 2. That's fine as well. This big one, ABD or DBA. Is that okay? Do you guys get the difference between the top picture and the bottom one, why I can't use just one letter? Okay, good. Angles are measured in degrees. 1 degree, how many degrees are in a circle? 360. So 1 degree is 1/360th of a circle. That's 1 degree because there's 360 in a circle, right? Angles for now are between 0 and 180. I don't want you to think that's always true. They can be more than that technically, but we'll get there someday, not today. All right, for this, let me come back to this in 2 seconds, okay? An acute angle, it's a cute little angle, right? So that's less than 90. A right angle is 90 degrees exactly, you know, because of the box, right? And an obtuse angle is more than 90, like that. Everybody already knew that when I first started talking about it, though. You guys are fine? Okay. This is kind of like when I was talking about the walls the other day, how they were equal, and then I said they were congruent, but it technically meant the same thing, right? So a picture of what we're talking about here. Measure of angle B equals measure of angle C, and this says angle B is congruent to angle C. So here's the difference. I'm going to draw 2 angles that look pretty close to the same. Let's say that's like, I don't know, 87 degrees or something. I'll call this angle B, I'll call this angle C. Do you understand that those are equal? Because they're the same, right? And because I know what they are, they're equal. So I get an M on them and an equal sign. If I had drawn it this way, okay, B's here, C is here, doesn't matter. I don't know what they are, but I do know they're the same. How do I know they're the same? Because that little thing, right? The little arc. So on line segments, each thing gets a tick mark. On angles, they get an arc to show me that they're the same. Sometimes you can have more than one. So if I had 2 arcs, I still know these are the same. Does that make sense? Okay. Does anyone still need this page? All right. Angle bisector. Again, when you hear the word bi, what do you think? 2. It cuts it into 2 congruent pieces, right? An angle bisector is a ray that divides an angle into 2 congruent angles. So for example, in this picture, do you see that angle 1 and angle 2 are congruent? You guys see they both have 1 arc on them, so that means they're the same. So this is what made that happen. So ray BC is an angle bisector of angle ABD because angle 1 is congruent to angle 2. Do you guys get what I just said? Okay. Does anybody still need that? Okay. Here we go. Let's do some examples. Don't shout anything out just yet. If you can't see yours, obviously you can look at mine either way. So what we're looking for is the vertex of angle 7. Don't say anything out loud. Give everybody a moment, all right? Locate where angle 7 is. See if you can figure out what the vertex would be. What do you guys think? Capital P, very good. Angle 7 is right there. Do you guys see that that's angle 7? And then P is at the vertex. So capital P. Yeah. Why wouldn't it be N or R? N or R. The vertex? So do you understand that this is the only angle 7 that we have? Do you get that? The number goes like in the, where the vertex is kind of? It always is there? Yes. So like when we look at this one, angle 2, angle 2 is this one. Okay. Is that okay? Yes. Okay. All right, so what is the vertex of angle 2? R. Very good. Did I lose anybody there? I'm going to erase what I have because that gets confusing, but are you guys okay? Okay, so don't say anything yet. You guys locate angle VNM. Maybe use your pencil super lightly like what I just did. So draw VNM, see where that is. Okay. Let's see here, VNM. So that's this angle here. Oopsies. Does everybody see that? Okay, so they want to know the sides of it. By definition, what are the sides of an angle? The rays. That's what I'm looking for. Yeah, so we're going to name them as rays, right? So how do I name this ray? What do I have to start with? You have to start with N and then the V. N is your end point or the vertex, right? On this ray, technically, this is a line segment. Do you guys see that I extended the line? There isn't more of a line there. So I wouldn't mark it wrong if you called that line segment NM, but by definition, it's supposed to be a ray. So I'm going to call it ray NM. What would be wrong is if you said VN. That would be wrong because you can't start with the V. Does that make sense? Okay. All right, the sides of angle 3. So let's find angle 3. Okay. So here's one side of it, and here's the other side of it. We have a lot of options. I could name this side ray RP. I could name it ray RT. Either way. So I'm just going to pick one. I'm going to say RP. Okay. This one only has one option. What's that? That's a Q, but yeah, RQ. Right? That's all right. Does everybody get what I'm saying? Okay. All right. Another name for angle 5. So again, find angle 5. I would probably draw it for a while until you're pretty comfortable. Okay. So angle 5 is right here. Oops. Okay. We can't call it P because why? Because there's a whole bunch of them. Do you see what I'm saying? So angle P could be this one, it could be this one, it could be that one, it could be that one. I don't know which one you're talking about. Does that make sense? So what can we call it? 3 letters. You have to have 3 letters. So you could say MPT. You could say NPT. You could say TPN. You could say TPM. No, when it's an angle, 3 letters or one if it's an option. Yeah, never more. Hmm? All right, give me a point on the interior of angle 5. Don't overthink that. Interior of angle 5. Here's angle 5. Here's the inside. So V. Everybody okay? Did I lose anybody? Okay. Ready? All right. Ray BA and ray BC are opposite rays. You can tell that by just looking, but when they tell us that, they want us to really understand that they make a, what? A line is what I was looking for, which means they add up to 180. Makes a line. That's what they're trying to tell us, okay? Ray BH, right here, bisects, cuts into 2 congruent pieces, angle EBC. So I'm going to draw that. Ray BH cuts this one into 2 congruent pieces. What that means is this piece is the same as this piece. Take a minute, look at that again. All I'm even doing is reading the directions. I haven't even read the question yet. Does that make sense? So I know that this is a line. It adds up to 180 degrees. They said this ray, BH, bisects angle EBC. So what that means is it cuts it into 2 congruent pieces. So angle EBH is congruent to angle HBC. Why did I give it 2 arcs instead of 1? Because there's already one there, right? Angle ABE is congruent to angle EBF just by the picture. I didn't even have to say anything. They just told me. Does that make sense? No. Well, yeah. Correct. What's bi mean? 2. Okay. You know what it means. Good job. Oh no, we have to know stuff. Oh. Okay. If measure of angle ABF is 7B minus 24, I'm going to label that. Just like the line segment questions we've been having, you drew your picture, you filled in what you knew. That's what I'm doing right now. I'm not doing any math, I'm just filling in what I know. Okay? So angle ABF, this one, right, is 7B minus 24. This arc is not indicating that that's the same as these two. It's just telling me this whole piece is 7B minus 24. Kind of like when I did the swoopies for the whole line. It's kind of the same thing. Does that make sense? Okay. Angle ABE, that's this one here, is 2B. I have filled in everything I possibly can. Okay. This would be very hard if you didn't draw that. When you draw it, it's super easy. Okay. So they want angle ABF, but I'm not even worried about that yet. What do I really have to find? I need to find B, right? I can't do anything unless I find that variable B. Okay? Say nothing yet. Look at your picture for just a moment and try something. Be like, I think this is what I might do. Okay? This is just like our line segment questions, but it's angles. It's the same concept. Does anybody notice anything at all that we might be able to do? Yeah. What about it? Okay. It's like a midpoint kind of thing, but with angles. Same concept. Yeah. So if this has one arc and it's 2B, uh-huh. Right. Yeah, she's right. This has one arc, right? This has one arc. If this is 2B, this is 2B. Everybody okay with that? These two angles make the big angle. How do I say that in math? These two combine to make this one. This piece plus this piece makes this piece, right? Nope, two B's. And if that happens for you, capitalize your B's then. That way it doesn't happen again. Either way, right? Do you guys get what I'm saying? Those two little pieces make the bigger one. Is that okay? In geometry, typically the first two steps are geometry. After that, it's easy algebra 1 that you should be pretty comfortable with. Try to solve for B and see what you get. Sure. Because if I don't find B, there's no way I can find that. I have to find the missing variable so I can substitute later. Well, ABF has a B in it, and if I don't know what B is, then I can't figure it out. They told me this was 2B. They told me that was 2B right here. I know that's 2B because they both have one arc on them, which means they're the same. What did you guys get for B when you're ready? It's okay. It's okay. It's 8. I'm going to do it for you. All right. That's obviously 4B equals 7B minus 24. Subtract the 7B from both sides and we get negative 3B equals negative 24. Divide by a negative and you get a positive. It's okay. Is everybody okay? Is that what they asked us for? No, they asked us for ABF. So angle ABF, angle ABF is 7B minus 24. I can look at my picture, or I could be like, oh, just kidding, it's right there. That's what they want. So measure angle ABF equals 7B minus 24. What do I do? Substitute. Yeah. So what's 7 times 8? Say it again. 56 minus 24 is, measure angle ABF is 32 degrees. Whoa, pretend I didn't cross it out and I circled it instead. So did we answer the question? Great. Well, that's the plan for a while, right? All right, the next question is the same picture again, but different information. So you have two choices. You can erase, don't do it yet. You can erase all this stuff and start over. But if you're someone who really wants to make sure you see that question with that part in your notes, then what you could do is just draw this picture again by that example and start over again. So either way, you're either going to draw this picture again with the second question that we have with it, or you're going to erase what we had the first time and start over. It's up to you, whatever you're more comfortable with, because it's your notes. You do what you want. Okay? For me personally, I probably wouldn't want to erase it. I'd want to see a whole new question, but you do what you want. It's the same picture. It's the same given information. So it's still opposite rays. It's still ray BH bisects angle EBC, which means this. That's still true. That hasn't changed. Okay? Yep, your book does that a lot. They'll use the same question but give you different information, and it saves pages in your book instead of drawing it like 15 times. Okay, so I'm going to label what I know. I haven't done anything fancy. I've just done the setup that we did on the last part. Okay, so angle ABH, that's this angle here, right? ABH is 5x minus 16, and angle CBH right here is 2x. I don't even care what they want. What do I need to find? I have to find X or I can't do anything, right? So don't say anything out loud yet. Whenever they give you pieces of the puzzle, you have to think, okay, am I going to shove those together and set them equal to something? Am I going to do half of that because it was an angle bisector? Am I going to do double that because it was an angle bisector a different way? Like, what do you think we're going to do? Yeah. Uh-huh. Yeah. Why did we write it again on the last one? Okay. Um, if this had one arc and this had one arc, it means they have to be the same. Does that make sense? That's why I knew that. And then these two together made this one. So literally this plus this equals that. Is that okay? Don't we have to, are you back on the last one again? No. X? Yeah. It's a whole new question. It's like erase everything that we did on the last one and start over. Same picture, different problem. So 2B isn't there anymore. It's totally gone. They didn't ask us for that. They asked us for ABF, so I didn't care what that was. Is that what you're saying?
Your question was, what do you think we're going to do? Trying to say we're going to do the same thing that we did on here.
Oh.
A different number.
Is that what you're saying? Okay. Not the same thing this time. What are we going to do with the 5x minus 16 and the 2x? What relationship do they have together? What do they make? They make 180. Who said that? Very good. Excellent. Do you guys see that this angle here and this angle here make a line, which means they add up to 180. So 5x minus 16 plus the 2x make a line. Okay? Do you guys get it? Okay. So solve for x. This is where you come in. You don't need me. Solve for x. This is the part you can do, right? Yes. Yep. It's okay. Take a minute. It's all right. I want you guys to understand it. Okay. What did you guys get for x? you should get 28, I'll wait for you, okay? If you don't get 28, tell me. Make me do it. I only do it if you ask from now on. So if you didn't get it, please tell me. Sure. Oh, yes, for the 28. I thought you were somewhere else. Sorry.
Okay. So it's supposed to be a really big angle degree, right?
We haven't found any degrees yet. So,
Is it backwards?
did everybody find 28? Okay. All right. Is that what they wanted? No.
No.
What they want? HBE. HBE is right here. Does everybody see that? Okay. Well, what on earth am I going to do now? I can't just plug it in. They didn't give me anything to plug it into. Good. HBE is right here, right? Okay. HBE is the same as HBC. What was HBC? 2x. So this is the same as 2x.
So we did 2 times 28, right?
Hold on. What did you say? If you go back to your original picture, this one has 2 arcs and this one has 2 arcs because of the angle bisector part of the question. Remember that in the very beginning? So if this is 2x, then this is 2x. Is that okay? So then obviously 2 times 28 is what we're doing. So measure of angle HBE is 56 degrees.
I'm confused on the last part.
I'm going to end the video and then I'm going to answer questions. Is that okay? It's getting a little long. So hang on a second.